Hi everyone, welcome to Physics Pathashala. What I noticed in the result, so many students lose their marks in MCQs and numericals. Okay, to get that good marks in exam, you have to practice more and more numericals and then MCQs. Already I uploaded first model paper MCQs and fill in the blanks. Please do watch that video. Today I am going to explain first model paper numericals. Okay, let's start with the first question. First question, calculate the potential at point P due to a charge of 400 microcoulomb located 9 cm away. Okay, second sub question, obtain the work done in moving a charge of 2 nanocoulomb from infinity to the point P. Does the answer depend on the path along with which the charge is moved? Okay, first write down the given value. So what is the given value here? Yes, here given. So, part A, potential at point P charge is charge. Q is equals to 400 nanocoulomb. Okay, here the 400 nanocoulomb. So, nanocoulomb is nothing but 400 into 10 to the power of minus 9 coulomb. The next here, located 9 cm away. Point P is located 9 cm away, nothing but the distance. So, R is equals to 9 cm. So, here, 9 into 10 to the power of minus 2 meter. This is the given value for the first sub-question. And then second sub-question, obtain the work done. So, what we have to find out here? Potential we have to find out. So, B is equals to question mark. Potential at point B we have to find. Here, obtain the work done in moving a charge. 2 nanocoulomb from infinity to a point P. So here, work done we have to find out here. And the charge 2 into nano is nothing but 10 to the power of minus 9 coulomb. And does the answer depends on the path we have to find out here. Okay, what is the first? I'm going with the first sub-question A. Here, we have to find out the potential at point P. Here, the charge 400 nanocoulomb is placed at the point, and here the point P, the located 9 cm away. Okay, at the point P, here we have to find out the potential. What is the formula? Which formula we have to use here? V is equals to 1 upon 4 pi epsilon naught Q divided by R. So this is the formula for the potential. We know 1 by 4 pi epsilon naught is nothing but the constant value 9 into 10 to the power of 9. What is the Q value here? Q is nothing but 400 nanocoulomb. So here 400 into 10 to the power of minus 9 coulomb upon R is nothing but the distance 9 into 10 to the power of minus 2 meter. Okay, here 9 get cancelled, 10 to the power of plus 9 minus 9 get cancelled. The remaining term 400 into 10 to the power of minus 2 is there in denominator. If we take the numerator, 10 to the power of plus 2 will come. So, the potential at the point P is nothing but 4 into 10 to the power of 4 volt. Okay, so this is the potential at the point P. So, now what we have to find out here? The second sub-question, obtain a work done in moving a charge of 2 nanocoulomb from infinity to the point P. From infinity to, we have to bring the charge. How much charge? 2 nanocoulomb of charge we have to bring infinity to the point P. Here, from here to the here. What about the work done we have to find out? Here, V is equals to, what is the formula? Work done upon charge. Correct? No? Here, using this, we can write work done is equals to potential into the charge. What is the potential here? We have to take the final potential to the initial potential. So, F minus Vi. Final potential into the initial potential into the charge. Okay? So, what is the final potential here? Already we find out 4 into 10 to the power of 4 volt. So, here write down 4 into 10 to the power of 4 minus of initial potential is 0. Okay, so how much? What is the charge here? 2 nanocoulomb charge. 2 nanocoulomb is nothing but 2 into 10 to the power of minus 9 coulomb. Okay, here just multiply 4 2s are 8 into 10 to the power of minus 9 and then plus 4 is nothing but 10 to the power of minus 5. The work done and the SI unit of the work done is 0. So this is the work done. We have from infinity to the point P to move the charge. So work done is nothing but this. Okay. Here another one question they are asking, does the answer depends on the path along which the charge is moved? Here remember, the work done only depends on the potential. The work done does not depend on the path followed by the charge. So it does not depends on path. Okay, it does not depends on path. So this is the answer for the first question. Okay, here let's move with the second question. Yes, here the circuit diagram they are giving. 1 ampere of current is entering to the junction. So this 1 ampere current is nothing but, so this is the I. Okay, so 1 ampere of current is entering to the junction. Yes, here this current is splitting has two current. One is the I1 current and then other one is the I2 current. Here this I2 current we can write 1 minus of I1. Okay, so this 1 minus of I1 is equals to the I2. And here the current flowing in this junction is 1 minus of I1 and in this junction is current is I1. Here the current is I3. The current in this junction is nothing but I1 minus of I3. So this is the current flowing in this junction. Okay, so this junction the current is I2 plus I3. So here in the place of I2 we can write 1 minus of I1 plus I3 current flowing in this junction. Okay, here naming this junction first A, B, C, D, E, F. Okay, here first use here what we have to find out in the forward network, find the current I3. I3 current we have to find out here. Here use the KVL to this junction. So apply KVL to the junction, we can get the I3 current. Before applying the KVL, find out first, we have to know the rules of the KVL. Here the product of current and then resistance in one direction and then loop direction. Here if we take the loop direction and then okay, here the loop, this is the loop direction for this junction and this is the loop direction for this junction. Okay, here I am considering product of current and then resistance. So is this current direction and then loop direction is the same means here we have to keep the negative sign for the current and then resistance. In the same way, if we take the current direction is exactly opposite to the loop direction, here we have to take the positive sign. Understand? Here consider apply KVL to the first junction. First one, apply KVL to A, B, E, F. A, B, E, F. Okay, A, B, E, F. Here, current is moving in this junction. I1, R1, product. Here, the current direction and the loop direction, both are in the same direction. So, we can take the negative symbol here. Minus product of current and the resistance, 10 into I1. Okay, here, this junction, current and the resistance. If we take this junction, current and resistance, what will come? Here 5 ohm resistance and then I3 current. So this I3 is exactly same direction to the loop direction. So we can take the negative symbol here, minus of 5 I3. Okay, here in the same way, the current is coming like this. In this junction, the current is exactly opposite. So this junction current is exactly opposite to the loop direction. Here we have to keep the positive symbol. Okay, so here the plus, what is the current flowing in this junction? 1 minus I1, and then resistance is 20 ohm. So here 20 into 1 minus I1. Okay, here there is no EMF present in this loop, so the EMF is 0. Okay, here the next I'm taking, just do this, 10 minus 10 I1 minus 5 I3 plus, just multiplying inside, 20 minus 20 I1 is equals to 0. Okay, take this pure number outside, and then I1 terms you add up first. Minus 10 I1 minus 20 I1 is that, so minus 30 I1 minus of I3, minus of I3. I am sending this pure number to the right hand side of the equation, minus 20. Here take 5 common. If you take 5 common, what will come? Minus 5 common, 6 I1 minus of I3 is equals to 4. Okay, consider this is equation number 1. Okay, here in the same way, apply KVL to the second loop. What is the second loop? B, C, D, E. So apply KVL to B, C, D, E. Okay, here consider the junction A, B, C, D, E. Okay, here we have to apply the KVL. First junction BC, current flowing in the junction is I1 minus I3. Okay, the resistance is 10 ohm. 10 ohm resistance is there. I1 minus I3 current is flowing in this direction. Okay, the current direction and then here the loop direction both are same. Here we can take easily the negative side here. So what will come? Minus 10. What is the current here? I1 minus I3. I1 minus I3. Okay, here the next, the second C and D, there is no resistance is that. No need to take the product of current and the resistance, and take the next junction D and E. So here the current direction, so this is the current direction and this is the loop direction. So here both are opposite to each other, so we can take positive symbol. Plus, what is the resistance in this junction? 5 ohm resistance is there, into what is the current flowing in this junction? I2 plus I3 current. So in the place of I2, we can write 1 minus I1, 1 minus I1 plus I3 current flowing in this junction. Okay, here in the same next junction. So this junction we have to take here. Yes, plus. Here why we are taking plus here? This current is exactly opposite to the loop direction. So the symbol we can take plus. What is the resistance? Here 5 ohm resistance. What is the current flowing in this junction? I3 current. Okay, is equals to, there is no EMF is produced in this loop, so EMF is 0. Okay, here just do the mathematical calculation here. 10 I1 minus into minus plus 10 I3 plus 5 minus 5 I1 plus 5 I3 plus 5 I3 is equals to 0. Okay, here I am grouping the terms 10 I1 and minus 5 I1. So here minus 15 I1. Okay, here 10 I3, here 5 I3 and 5 I3 plus 20 I3. Plus 20 I3, and send this pure number to the right hand side of the equation, minus 5 I3. Okay, here the take 5 minus 5 common here. If you take minus 5 common, 3 I1 plus 4 I3 is equals to 1. Okay, so I'll consider this is the equation number 2. Okay, here the apply KVL to B, C, D, E, B, and you can take here also A, B, C, A, B, A, F, A. If you want, you can take this. Okay, here take minus 5 common. If you take minus 5 common, here 3 I1 minus 4 I3 is equals to 1. So here the considered equation 2. So this is equation number 1 and this is equation number 2. So actually here 6I1 plus I3 is equals to 4. This is the equation number 1 and this is the equation number 2. Solve equation 1 and 2. Here we will get I3. 6I1 plus I3 is equals to 4. This is equation number 1 and then 3I1 minus 4I3 is equals to 1. Here multiply this equation by 3 and multiply the second equation by 6. So what will come? 18I1 plus 3I3 is equals to 12. Here 18I1 minus 24I3 is equals to 6 ones are 6, 6. Okay, so here the negative symbol, positive symbol, and here the negative symbol. Okay, so plus 18I1 minus 18I1 get cancelled. Here the 24 plus 3 is nothing but 27I3. 27I3 is equals to 12 minus 6 is nothing but 6. Okay, here I3 is equals to 6 upon 27. Here 3 2s are 6 and 3 2s are and then 3 9s are 27. So 3 9s are I3 is equals to. Then here I3 is equals to 2 upon 9. So what is the 2 upon 9? Here 2 upon 9. Take cancel here. 0.22 is the answer. Okay. Answer for this question here 0.22 ampere of current. 0.22 ampere of current flowing in this circuit. Okay. So this is the method to solve the circuit type numericals. Okay. Here let's go with the next question. And here an AC source of frequency 50 Hz is connected in series with an inductor of 1 Henry. Okay. Here a capacitor of 90 microfarad and a resistor of 100 ohm. Does the current leads or lags the voltage? Calculate the phase difference between the current and voltage. Okay. Yes, first write the given value. First, here the frequency they are giving. So frequency is nothing but here the 50 Hz. So next inductor. Inductor is nothing but L is equals to 1 Henry. And capacitor they are giving. Capacitor C is equals to 90 microfarad. Microfarad is nothing but 10 to the power of minus 6 farad. And here and resistor they are giving R is equals to 100 ohm. Okay, here does the current leads or lags the voltage? We have to find out. Here before going to solve the numericals, we have to know this. We know that here XL is greater than XC. What will happen? Here the voltage leads current. If XC is greater than XL, what will happen? Current leads voltage. Okay, remembering this point. Here first I am going to take XL. We have to find out XL. XL is nothing but inductive reactance. What is the meaning of inductive reactance? Opposition offered by the inductor is nothing but inductive reactance. Okay, XL formula is nothing but 2 pi FL. Okay, here 2 into 5 is nothing but 3.14 into what is the frequency? 50 Hz. 50 Hz frequency into the what is the inductor here? Inductor is 1. Okay, here 50 into 2, 100 into 3.14. So here the XL value is nothing but 314 ohm. Okay, so this is the inductive reactance value. In the same way, we have to find out the capacitive reactance. XC. What is the formula for a capacitive reactance? 1 upon 2 pi FC. So what is capacitive reactance? Opposition offered with the capacitor is nothing but capacitive reactance. Okay, here find out, substitute the values. 1 upon 2 into, what is pi here? Pi value is 3.14 into frequency is 50 into, what is capacitor? Here 90 into 10 to the power of minus 6. 90 into 10 to the power of minus 6 farad. Okay, here 1 upon 2 into 3.14 into 50 is nothing but 314. So write down 314 into 90. 10 to the power of minus 6 there in numerator. If we take the denominator into 10 to the power of plus 6 will come. So we can take here 10,000 into 10 to the power of 2 upon this value 314 into 90. A calculator. Okay, here 314 into 90. So what is the value? What is the value here? 28260. 28260. Okay, so this is the value. And here XC is equals to 1000 upon, do that, 10,000. Sorry, 10,000 divided by 28260. So what is the value? 0.3538 into 10 to the power of plus 2. Okay, so here the XC is nothing but shift the points 35.3 ohm. So this is the capacitive reactance. Okay, here compare XC and XL. So XL is 314, XC is 35.3. Okay, so XL is greater than XC. Here, therefore, XL is greater than XC. Okay, so XL is greater than XC means what? So voltage leads current. But here they are asking current leads and lags. So current lags behind. Here I, current lags behind voltage. Okay, here the next one we have to find out. So this is the current, does the current leads or lags the voltage. Let's calculate the phase difference between the current and the voltage they are asking. Yes. Okay, here. Let's start with the phasor diagram. Here I am taking, this is the resistance, current, and then this is the resistance R, and here this is the XL and this is the XC. Okay, so XL is greater than XC is, so here the phasor diagram comes here in this direction, XL minus XC, and here the impedance Z. This is the phase angle. Here if we take the triangle, this line is exactly parallel to the XL minus XC. So this value is XL minus XC. Okay, so what is the formula? Here the tan phi is equals to, what is the tan theta? Opposite upon adjacent side. So XL minus XC upon R. What is XL here? The XL value is 314. 314 minus of XC value is 35.3. 35.3 upon 1000. Okay, so take calci here. Take calculator. Here 314 minus 35.3 is nothing but 278.7. Okay, so here 278.7 upon 1000. So the value of tan phi is equals to 2.78. Okay, so 2.78 is the tan phi value here. Here we have to find out phi. Here the phi is equals to tan inverse of 2.78. Okay, so what is the value of tan inverse of 2.78? 70.2 degree. Using the clock table, we can find out this value. So here this is 70.2 degree. So this is the phase difference between the current and then voltage. Okay. This is the yes. Let's move with the next question. Here, based on the prism, they are asking the question. An equilateral prism is made up of a glass of unknown refractive index. A parallel beam of light is incident on face of prism. The angle of minimum deviation is 40 degree. Find the refractive index of material of the prism. If the prism is placed in water, of refractive index is 1.33. Find the new angle of minimum deviation of the parallel beam of light. Okay. Here, consider the prism. Okay. Here, prism. Yes. So here what they are giving refractive index, parallel beam of the light is incident on the face of the prism. Angle of minimum deviation is nothing but 40 degree. Here, this angle of minimum deviation D is equals to 40 degree here. Okay. So here this prism is equilateral prism is nothing but this angle is 60 degree. Here, this is in the air medium. Here, what we have to find out? And refractive index of glass we have to find out here. Okay. And in the same way, take the refractive another prism. Okay, here I am going to take the prism. So inside of the water prism I am considering. Here the refractive index, this is the angle, equilateral triangle 60 degree. So this is the water medium. Okay, so refractive index of water, what is the value of refractive index of water they are giving? 1.33. Here what we have to find out here? Here the angle of minimum deviation we have to find out inside of the water. Okay, here this is the air medium, this is the water medium. Here the light ray passes from water medium to the glass medium. Okay, here the light ray passes from air medium to the glass medium. Okay, here first find out the refractive index of glass. What is the formula? Ng is equals to sine A plus D upon 2 whole divided by sine A by 2. Correct, no? Here, sine A is nothing but what? 60 plus deviation is nothing but 40. 60 plus 40 is nothing but 100 upon 2 is nothing but 50. Sine 50 upon sine 60 upon 2 is nothing but sine 30. So, sine 50 degree upon, what is sine 30 value? Sine 30 is nothing but 1 by 2. So, 1 by 2. Okay. Here, Ng, refractive index of glass is equals to 1 by 2 is nothing but 2 sine 50. 2 sine 50 degree. Okay. So, here Ng is equals to 2 into sine 50. So, what is the value of sine 50? 0.766. 0.766. Using the clock table, we have to use this sine 50 degree. Okay. Take calculator and calculate this value. 2 into 0.766. So, what is the value? Ng is equals to 1.53. So, this is the refractive index of glass. Here, in the same way, we have to find out the refractive. Here is the second condition. The prism is placed inside of the water. Here, relative refractive index we have to find out. What is the relative refractive index? Refractive index of glass with respect to the water is equals to, what is the formula? Sine A plus D dash is nothing but refractive index, means relative angle of minimum deviation inside of that water we have to find out here. Upon D whole divided by sine A by 2. Okay, here. And Refractive index of glass with respect to water is nothing but we can write Ng refractive index of glass upon refractive index of water. Here sine A plus D upon 2, D dash upon 2 whole divided by sine A is nothing but 60 divided by 2 is nothing but sine 30. Refractive index of glass value is what? 1.53. Write down 1.53 upon. Refractive index of water is the given value 1.33. Write down as it is 1.3. Is equals to sine A plus D dash upon 2 whole divided by sine 30 degree. What is the value of sine 30? 1 by 2. Correct, no? So 1 by 2. So what is 1.53 into 1.33? Use a calculator. 1.53 divided by 1.33. So here 1.150 is the value. Here 1.15 into, here 1 by 2 is there. Just do the cross multiplication here. 1 by 2 is equals to sine A plus D dash upon 2. What we have to find out here? D dash. Yes, let's do the multiplication. Yes, 1.15 upon 2. So what is the value? 1.15 divided by 2, 0.57. 0.575 is equals to sine A plus D dash upon 2. Okay, here sine inverse. So see, we can take sine inverse of 0.575 is equals to, what is the value here? A plus D dash upon 2. Okay, what is the value of sine inverse of 0.575? So using the clock table, we have to use this 35.1 degree. This is sine inverse of 0.57. Okay, is equals to, what is the value? A plus D dash upon 2. Here, let's do the cross multiplication. 35.1 into 2. So, 35.1 degree into 2. So here 70.2 degree minus is equals to A plus D dash. Okay, so here the 70.2 degree, A is nothing but 60 minus of 60 is equals to D dash. 70.2 degree minus 60 is nothing but 10.2 degree is equals to, this is the angle of deviation inside of the water. Angle of deviation of the prism inside the water. Okay, so this is all about the prism, equilateral prism numerical. Okay, yes. Here, this is the angle of Ng is the refractive index of the glass is nothing but 1.53. So refractive index of water is nothing but 1.33. Using these two values, we have to find out the refractive index of this angle of minimum deviation of the prism when the prism kept inside of that water. Okay, here this is all about the numericals of the first model paper. I hope this video is very helpful for you. If you feel this video is helpful, please don't forget to share, like and subscribe this channel. Thank you.